Chatbots have changed. This is what LLMs used to do. They used to write one word at a time in a sequential order. But this is what LLMs do right now. They just got 10 times faster. And the difference between them is the difference between a printer and a painter. So a printer basically prints from left to right in a sequential order. But a painter paints in a completely random order. The left eye first, right eye second, mouth third, leaving lots and lots of gaps, which over several iterations he keeps filling, giving us the final picture. And our LLMs are now doing the exact same thing. In the first iteration, it spits out random words in random order. There's a lot of gap in between, which the AI fills in subsequent iterations. Now, the biggest benefit of doing like this is basically speed up. Before, you are outputting one word every single time, but now you output 10, 20 words in one single pass. So, obviously, the system is 10, 20 times faster. But this seems obvious to the human eye, and this seems quite literally impossible. But this kind of a switch is not new to AI, it's happened before. Back in 2017, when the landmark paper Attention is All You Need got released, AIs did the same thing in reading. You see, before 2017, AIs were reading like how humans would read, one word at a time, sequentially, line by line. These were called RNNs back in those days, where every single time step you read a new word. But after Transformers, AI started randomly reading multiple words from the text in a very jumbled, disorganized way. Just like how AI writes in our case, in this kind of random, jumbled order. But we stopped RNNs and moved to Transformers. We stopped sequential reading and moved to random, jumbled reading because that's what made the AIs more intelligent. But in our case, writing, we are not doing this for more intelligence. Because in this demo, on both sides, the AI is writing the same answer and the intelligence is exactly the same. So now in 2026, we are doing this switch purely for speed reasons. But the crazy part is, these outputs that I've been showing to you, they are actually not AI's output. They are our output. So instead of these fragmented words, the AI actually outputs the entire message at every single iteration. But we randomly choose some words like these and delete the others. And then this corrupted message that we created, we give it back to AI as input and then ask the AI to kind of recover the lost message. So AI sees this and again brings back the original message. Here I'm showing the same message because it's a demo, but in practice, AI writes a completely new message every single time. And every time, on top of the previous words, I choose more words and again I destroy all the others. So it's basically like giving a prompt, getting an answer, but we keep clicking the redo button again and again. But the problem is with each answer, the words keep changing. So it's Jackson 5 now and humanitarian efforts in the next message. So we are making sure the words we select in the first message will persist across all the messages by adding these words as part of our input for the second iteration. This way, all the other words may change, but the words we select alone will stay untouched. So this way, we are making the AI attempt multiple times, but then we are merging and combining all those attempts into one single output. But why do we need to do that? Every single attempt of AI looks good enough. So why do we need to do all this dance to combine multiple answers? Well, that's because in this demo, I'm using Gemini to show you these four attempts. And Gemini is a one word predictor. It only predicts one word in every single iteration. But now we are moving to a multi word predictor where the AI produces all the words in one single iteration. So single word predictors are very accurate. So every attempt of Gemini is pure gold here. But when we move to a multi word predictor like this one, we lose accuracy. So when we reduce the speed to one word at a time, we increase the accuracy. But when we increase the speed and go to multiple words at a time, we drop in accuracy. In other words, if we move our Gemini to the new version where we output multiple words at a time, then this text right here will turn into pure gibberish. The AI will start making lots and lots of mistakes. This is why people prefer one word predictors instead of multi word because even though it generates the whole text in one step, it's very, very inaccurate. And even though the one word predictor takes a long time to produce the whole text, it's very, very accurate. Now in this demo, I'm showing you the same text on both sides. I'm calling one accurate and one not. Bear with me. It's a very bad demo. I agree. But that's because I'm able to demo Gemini in only this one word prediction mode, as the multi-word prediction mode is only available to researchers. So if you can look beyond the numerous demo flaws I made and look at the content, you will see that when AI predicts one word, it's slow but accurate. And the same AI, if we ask it to predict multiple words, it's really fast but really inaccurate. But if we delete and persist some of the words randomly and ask the AI to redo some 10-20 times, then suddenly it starts to become accurate again, giving us both speed as well as accuracy. And this magic right here is called as diffusion. So, what is diffusion? How does it correct this inaccuracy? And why is this inaccuracy getting created in the first place? The answer to these questions is what this video is about. They say a woman's heart can truly be understood only by another woman. Similarly, I believe an AI's heart can truly be understood only by another AI. But here, we're going to make an attempt. So if you like this video, consider subscribing and let's jump right in. Now, in order to understand the inaccuracy that occurs when we move from one word to multiple words, we need to understand how the AI outputs words, and the simple answer is it doesn't. In the beginning of the video, I said AI outputs like this, and then I said it doesn't. It outputs like this. But now I'm repeating the twist one more time. It doesn't output like this, it outputs like this. Probabilistic distributions. So previously we did some post processing and converted this to this using diffusion, and now we are converting this to this with another post processing called sampling. Now I know probabilistic distributions and sampling sound all weird to you, but in simple English, this just means the AI is giving us choices and we are doing the choosing. Now, in order to see that in action, let me give you an example that I saw in another YouTuber's video. So here the YouTuber Gaurav is asking the question, what is the best programming language in 2026? And the answer to that takes multiple parts. Say this is one answer to the question. If you notice these two words, there are multiple options for those words. If I choose safety instead of popularity, then the answer becomes C++ instead of Python. Similarly, if I choose speed, then the answer becomes Go. So what I choose here depends on what I chose here. So when we try to extract the same answer out of AI, this is what happens. I get a bunch of probabilistic distribution functions where I get one for each word in the sentence. Here I'm focusing only on the fourth word and the eighth word. So I'm just showing two functions here. And since we have three options for the fourth word, we have three peaks in this graph here. So basically the x-axis represents all the words in the English language and the y-axis represents probability for each word. So this is how AI gives us these three choices to us. It gives us three peaks. And then our sampler, which is a small code that we write, randomly picks one of those peaks. So if our sampler chooses popularity from these choices that AI gives, then at the eighth step, AI will give us this function where the word Python gets the highest probability and words like Go and C++ get 0 because the right answer for popularity is Python. But if our sampler chooses differently at the fourth step, say it chooses safety instead of popularity, then AI changes the graph at the eighth step to reflect the answer C++. So this is the true advantage of a one word predictor. At every time step, AI gives us choices and we make a choice. Then we send the prompt plus whatever choices we made to the AI as the next input. AI looks at our choice and gives us the next function, the next set of choices. This way, we control the path of the sentence and AI adapts to the choices we make. At every single step, AI sees our work and does course correction. And now it becomes clear why inaccuracy occurs. In one word prediction, after our dumb sampler samples a word, we get an AI review that modifies and updates the distribution for the next word. And again, our dumb sampler randomly samples a word, and again, AI reviews this dumb sampling. But multi-word prediction finds this entire process very slow. So in multi-word prediction, we are going to ask the AI to give all its predictions for the next 500 words all in one shot, so that our dumb sampler can output 500 words by randomly selecting peaks without understanding the meaning of each word and how it all connects into a sentence, thus producing inaccurate gibberish. So if we redo our previous example with multi-word prediction, because we are not calling the AI for review at every single step, it is not able to adapt the function based on our choices. And because we are asking all the functions in one shot, the AI is going to give this function as it doesn't know what choice we are going to make here. So when we don't show what we choose here, AI is going to give us back all three options. And now when our random sampler comes in and starts picking peaks randomly, it will start producing wrong answers by connecting speed with C++ and safety with Python. And the problem doesn't stop with wrong answers, it also starts giving wrong English. Say you're going to go to Europe in the near future. Then there are two ways to say it, where when you start the sentence with I am, the probability for the words go to increases. But when you start the sentence with I will, the probability gets flattened. But because the choices are not going to be shown to AI will give an average of these two graphs, meaning sometimes go to comes and sometimes it doesn't. And our random sampler will end up picking these two peaks, giving us a combination of both sentences that sounds like pure gibberish. So when we move from one word to multi-word, we move from multiple choices for words to choices for multiple sentences, where our sampler randomly connecting peaks across functions ends up creating a sentence that is a mix of multiple sentences, where the head comes from one sentence and the tail comes from another. So to fix this, we are going to add in a new diffusion step, where we delete at least 400 words approximately. So from the 500 words we sample, we'll at least delete 90%, 95% of them and go back to sparse sampling instead of continuously sampling every single word. Because this gap between two sampled words gives AI the opportunity to correct any mistakes that the sampler makes. So say we run multi-word prediction and our sampler samples go for popularity instead of Python. Then AI can creatively modify the distributions so that in the next sampling, the sentence corrects itself. Now, if I apply diffusion and delete some of the words, so instead of I would say, AI now says choose Python, not Go. So this way, a sentence that was wrongly recommending Go was corrected using diffusion and AI review. So if we go back to the pipeline, we are getting back the AI reviews, but now it's not for one word, it's for 500 minus 400, 100 words. So we get back the loop of AI reviews just like before. The only difference is previously it was for one word, now it's for 100 words, making it 100 times or 200 times faster depending upon how many words you allow after the diffusion step. So from bulk sampling, we have got our speed, and from diffusion, we have got our accuracy. So any mistake we make, diffusion would get rid of it. But if we are not lucky and diffusion gets rid of some other words, then our AI review will jump in and fix it. So the sampler and AI review are like hero and hero's friend in all movies. So when hero and hero's friend get caught doing some mistake, then when people start interrogating them, they will start improvising in the moment, but not in sync with each other. So when the friend says, "We were at the hospital," then hero gets surprised and acts along saying, "Yeah, we were at the hospital." Similarly, every word the sampler chooses is like a surprise to the AI, and AI improvises in the moment, adapting to the choices the sampler makes. But for an even better analogy to help understand this mechanism, imagine we are writing an essay and the sampler is kind of picking all the headers for us by doing its sparse sampling, leaving lots and lots of gaps. And the AI is coming in and filling all the paragraphs, just like how we prompt and AI gives us back responses. So, this is the diffusion concept. And if you like this video, consider subscribing because I'm going to be making lots and lots of explainers where I'll try to make this complicated AI field intuitive and easy to understand. So let me know if this video helps. I'll see you in the next one.